G'day ladies and gentlemen, welcome back to Term 2 2020, and we're going to start off our lessons today with, I guess, a little bit of a talk about the Earth structure. So first little note, structure of the Earth. That's your heading. So, when we're thinking about the structure of the Earth, we're really thinking of the layers of the Earth. And for that, we're going to draw a nice big diagram. So I'm going to start with a nice big V section. Okay, let's use some different colours to represent. We're going to start off with our first layer. And it's our central layer in the Earth. Everyone will know this from year 7, that this is called the inner core. And we know that it's solid, and it's also made out of primarily iron and nickel. It's also very, very dense. It has the greatest density of any sort of layer of Earth, and that is around 13 grams per cubic centimetre. So it's very, very dense material. Our next layer, around the outside of this one, is the outer core. I should have mentioned actually that the thickness of the inner core, and by the way, this isn't to scale because I've not done a very good job of scale, is about 1,220 kilometres. It should be more like there actually, sorry. The outer core is about 2,250 kilometres thick. It's made of iron and nickel as well. But it is liquid. How do we know it's liquid? Well, it's all down to do with seismic waves. There are different types of seismic waves. There's primary waves, which are the first type of wave that strikes in an earthquake. Then we have secondary waves, followed by surface waves called Rayleigh waves and Love waves. Now, we don't need to go into that detail, but primary waves and secondary waves will only go through certain materials. And secondary waves, when they go through the Earth, they stop when they get to the outer core. That means that they can no longer penetrate the outer core. That means it must be a different structure to the rest of the Earth itself. We'll come back to that a little bit later in the coming weeks. So we have our outer core and we have our inner core. Let's move on to the mantle. I'm going to draw my mantle here. Again, not to scale, guys. Here's our mantle. About 2,890 kilometres deep. It's made out of molten rock. When I say molten rock, it is not a particular rock itself, more like a molten mixture of material that will become rock if it's allowed to cool down. But because it's at this temperature, it remains in a mineral-less form, and essentially it's a group of compounds and elements, all just, I guess, in a sort of semi-solid lump within the Earth. It does not form rock yet. It would only form rock if you brought it to the surface. Now, let's go to our top 2 layers. And I'm going to draw a little thin layer here. Draw a slightly thicker layer here. Alright, so here we've got our crust, and there are 2 types of crust. One called oceanic. Now, oceanic crust, and this one here, I'm going to just draw my little line down here, this is continental. Oh, I will mention also, I should have done this before, is that the outer core has a density of 11 grams per cubic centimetre. And the mantle has a density of about 5 grams per cubic centimetre. Can you see we've got lowering density as we move upwards? All right, let's go back to our crusts here. Oceanic crust and continental crust. Oceanic crust, obviously, it forms over the ocean, and it's between 5 and 8 kilometres thick. It's made out of a rock primarily called basalt, and it has a density of 3 grams per cubic centimetre. Continental crust can be anywhere between 30 and 80 kilometres thick. If you think about thick parts of the continental crust, that's going to be our mountain ranges, and the thinner parts of the crust are going to be large flat plains. And if you think about Australia, Australia would be fairly thin in terms of its continental crust. Why? Because we haven't had a great deal of tectonic activity, and we've had lots of erosion, slowly making the surface of Australia, I guess, thinner and thinner and thinner. All right, so the density of our continental crust is 2.2. All right. Now you might have noticed here, I've left something out. There's like a bit of a gap. I haven't done that by accident. I've done it on purpose. Because you see, there's 2 layers in here that I've not put in, and you would not have known, you wouldn't have studied previously in the past. Let's add them in now. I'm going to add a layer. That's going to go about here. I'm going to colour it. It's supposed to be yellow, but it's coming up as green. Cool. And this one here, I'm going to colour it orange. And please remember, this isn't to scale. I've not done a very good job at scale on this. So let's look at these 2 layers. They're really interesting. I'm just going to draw this one over here. I hope you guys can see that all right. Let's go with this top layer here. This top layer here is called the lithosphere. It is solid and it is brittle, and it is made of both the solid crust and this part of the mantle here. It's the very, very upper mantle, and it's essentially it's solid magma. It's solid. This next layer here is really interesting. It's called the asthenosphere. It is solid, but this solid behaves like a liquid. Now, if you think about a solid that behaves like a liquid, if you think about Play-Doh, Play-Doh is a solid. However, you can mend it and bend it around so that it actually can move like, in a way, you can move it like you would move a liquid. So, here we have the asthenosphere, and we have the lithosphere, continental crust, oceanic crust. Let's talk about densities. I'm going to write it here. Asthenosphere is 4 grams per cubic centimetre. and the top of the lithosphere is 3.5 grams per cubic centimetre. So you can see we've got this real change in density. We've got the asthenosphere, we've got the lithosphere, mantle, outer core, inner core. I will write one bit more about the asthenosphere, and that it flows. The asthenosphere will flow. Yes, it's a solid, but this solid will flow like a liquid. And we have inside the asthenosphere convection currents that move this material around. But we'll talk about that a little bit more later on. So the last little bit I'm going to talk about today is how this all formed. Well, just get my continental, my layers back. How this all formed was really interesting, because when the Earth formed, it was once just a molten mass of magma. 4.56 billion years ago, the Earth formed. And when it formed, it was literally a ball of molten rock. This is the key word here, molten. So, the Earth had formed, and we can maybe even just forget about this for a second. We can think about the early Earth, and it would have been just volcanoes everywhere on the surface of the Earth, and it would have been a pretty terrible place to live. I'm not even talking about continents right now. Well, if we think about what's happening here, and we go back to our material that we had, and we look at our 13, 11, 5, 4, 3.5, 3, and 2.2. Well, this material, it's no coincidence, I guess, that it is all at these in particular layers. Because at the time when the Earth was forming, all of the dense material was sinking to the centre of the Earth. So it was sinking to the centre of gravity. So that's why we have those layers. We have these layers because they're made of material that sank first. If you wanted to try this in practice, go out and dig a big, dig a big pile of dirt up from the garden and pour it into a glass of water. And what you'll notice, that's your glass of water, is all the heavy rocks will fall to the bottom first. And that as it moves upwards, the material gets smaller and smaller and finer and finer. That's because the heaviest is on the bottom. And it's the same principle when the Earth was formed. All of the heavy material, like iron and nickel, was pushed to the centre of the Earth, where it formed a solid, dense lump. And around the outside of that, we had a not so solid lump. It was liquid, but it was made out of the same materials. The mantle is made out of a lot of metallic elements, so iron and cobalt and nickel and copper and zinc and gold and silver, and all of these materials are quite heavy, so they will sink into this part. Up here in the asthenosphere, well, then we still have a lot of magmatic material, but it's again quite dense it has a lot of metallic minerals in it, which are quite heavy. And it's right at the top here we get some of our lighter elements like silicon. And much of our material in the upper crust is made of these very light elements. And much of the material in the inner core is made out of our very heavy elements. Okay, so that's the structure of the Earth. I hope you guys are going well with the rest of your activities, and I'll talk to you later.